All right, let's get right into it. Today, we're going to break down something that's causing a lot of headaches in AI development: predictability. We're looking at a framework called OpenSpec, and it promises to bring some serious, much needed structure to the chaos. So let's start with a little reality check. You've been there, right? You spend a ton of time crafting what you think is the perfect prompt for your AI coding assistant. You hit go, and you get something back that, well, it kind of feels right. The vibes are there. But when you actually dig in, you realize it completely missed the point. That, my friends, is what we call vibe coding, and it's probably costing you hours, if not days, of rework. So what's really happening here? The issue isn't that the AI is bad or dumb. The problem is that it's guessing. When we give it these vague instructions, or when the context is scattered all over the place, in Slack messages, old design docs, or just in our heads, the AI has to fill in the blanks. It's just trying to catch the vibe. And that drift from your actual intent? Well, that's exactly where all the unpredictable results and costly rework come from. Okay, look at this. This slide really lays it all out. It's the difference between trying to build a house on sand versus building it on a solid foundation. On the left, you have vibe coding. It's all vague prompts and scattered context. It's messy, it's unpredictable. But now, look to the right, spec-driven development. Here we have executable specs, a single source of truth. The output is deterministic. And why is that? It's because we're aligning on the blueprint before we start laying any bricks. It's all about preventing problems, not just fixing them later. So how do we get from that chaos on the left to the clarity on the right? Well, it's not about a fancy new tool or a better AI model. It's about a mental shift, a whole new philosophy, really. And the idea is powerful because it's so simple. Structure before code. Get the blueprint right first. The absolute core of this philosophy is the single source of truth. Now, don't think of this as just another documentation folder that's going to be outdated in a week. No. Think of it more like a living constitution for your project. It's the one place that defines exactly what the system is supposed to do, and it evolves with the system. The code and the intent never fall out of sync. By the way, if this is the first time this idea of a living spec has finally clicked for you, do me a favor and subscribe to the channel. I'm making it my mission to clear the fog on these topics for everyone. All right, so we've got the philosophy down. Now let's get our hands dirty and look at the actual blueprint. How does OpenSpec take this idea of a single source of truth and make it a reality? It's actually a pretty clever and elegant system. Okay, so imagine your project is a library. You've got the main collection, right? These are the books everyone relies on, the established truth. You can't just go in there and start scribbling in the margins. So what OpenSpec does is create a two-folder model. It essentially builds a wall between your stable, trusted library and the workshop where you're building all the new stuff. And here it is, laid out plain and simple. On one side, you've got the specs folder. That is your library, the unified source of truth. It contains a perfect record of everything your system can currently do. It's protected. Then on the other side, you have the changes folder. This is your workshop. Every new feature, every single bug fix happens in its own little isolated space right here. You can experiment, make a mess, and it won't affect the main library until it's absolutely perfect and ready to be merged. So how do we update the main library from our workshop? Well, we don't just rewrite the whole spec. That would be crazy inefficient. Instead, we use what's called the delta concept. Think of it exactly like track changes in a Word doc. You just mark what's been added, modified, or removed. It's a crystal clear set of instructions for the AI, telling it precisely what to change, nothing more, nothing less. Now let's zoom in on one of those little rooms in our workshop, a single change. What's actually inside? It's not just a bunch of code files. It's a neat, self-contained package made up of 4 key artifacts. This right here is the secret sauce. It's a 4-step journey from a simple idea to executable code. First step, the proposal.md. This is the why. What problem are we actually trying to solve? It gets everyone on the same page. Second, the spec.md. This is the what. What are the exact requirements with concrete examples? No ambiguity allowed. Third, the design.md. That's the how. This is the technical blueprint, the architecture. And finally, tasks.md. This is the roadmap, a step-by-step checklist for the AI. It's like giving it perfect turn-by-turn directions. Now, you might be thinking, wow, I wish I'd known this sooner. Well, you're here now. Make sure those notifications are on so you don't miss the next session. Okay, so we've walked through the philosophy and the mechanics. But why does any of this actually matter? What's the payoff here? This is where it all clicks. This isn't just about being neat and tidy. This is about fundamentally changing how we work with AI. So what do you get? First, deterministic outputs. You get predictable, stable code because the AI isn't guessing anymore. It's following a strict plan. Second, it's incredibly review-friendly. You, the human, approve the spec before any code is written. Just think of all the wasted effort that prevents. Third, it supports brownfield projects. That means you don't have to burn your old code base to the ground. You can start using this organically for new features. And maybe best of all, zero API keys. This whole thing runs locally as a lightweight tool. No external dependencies, no security nightmares. And this really is the big idea, the manifesto, if you will. We need to stop treating AI like some quirky, unpredictable chat tool that we just throw prompts at. The goal here is to transform it into a standardized, reliable engineering tool, something as dependable as your compiler or your version control system. A true partner in the development process. So I'll leave you with this question to think about. As AI gets more and more powerful, do you think these kinds of machine-readable specs are just a nice-to-have? Or are they the absolute future of how we build software? Is this kind of structured partnership the only way we're going to manage the incredible complexity of what's coming next?